Hey class, Mr. Moyden here with a couple of examples to help with your homework. These all relate to discounted loans, the topic we talked about in class, as well as how it relates to financial instruments that the government issues called treasury bills. So let's take a look at the first one. You need to borrow $3,500 for a car repair, and you can repay in 8 months. You want to minimize the amount of interest you pay, and there are two offers presented. A discounted loan with a 9% rate, and a simple interest loan with a 9.5 rate. So which loan should you take for the least amount of interest paid? So there's two different methods here. There's discounted as well as simple interest. So we're going to look at both, and we're going to do basically both problems simultaneously, or one after the other, I should say, and then figure out which one has the least interest payment involved. Right? So let's do the simple interest one first. It's the one we're typically familiar with. So the amount you pay is equal to the principal times 1 plus the rate as a decimal times the time in years, right? So that's from class and from years past. So $3,500 is how much I borrow, times 1 plus the rate as a decimal here would be dividing by 100.095 times the time in years, so 8 months. 8 divided by 12 will give me 2/3 of a year, I believe. And all we've got to do is throw all that in the calculator and see what we get. So let's take a look. We have 3,500, 1 plus 0.095 times 2/3. Let me just make that 8/12 to be extra precise. That's the length in years of our loan. And we get this amount right here. The amount that we actually pay is $3,721.67. Now remember, we borrowed $3,500, so if we pay this back, to actually find the interest, we need to subtract away the principal that we just borrowed. So from that amount, subtract the $3,500 that was borrowed in the first place, and the amount I actually paid the bank to borrow that money was $221.67. So that's my interest on the simple model at 9.5%. Right? We also learned, and that's the typical way that we learned in the past, but the new way is called discounted interest, where it's deducted from your original amount. So the formula for that we learned was Q is equal to L times 1 minus RT. Now remember, Q is the amount that you as a borrower receive. And in this case, you need that amount to be $3,500. The question is, how much does the bank actually consider that loan when they get it back? So in other words, how much money will you pay back? That'll be L. So this is our unknown. This is $3,500, and the other two numbers are the same as they were before. So all we've got to do is solve for L. $3,500 is what I want to have. The amount of the loan is going to be L times 1 minus the rate, which is still 0.095, times the time, which is still 8 months, so still 8 out of 12, which is 2/3. So keep in mind, this is 8/12 back here, just simplified. Alrighty, so here we're going to be a little bit more careful. Notice that this is all just, 1, 0.095, 8/12, those are just numbers. So let me go ahead and simplify that a bit. 1 minus 0.095 times time. So all that business there simplifies to 0.9366 to round it properly, times L is equal to $3,500. So to solve for L, the amount I'm actually going to pay back, divide both sides by the coefficient here. $3,500. And I'm going to show you a little trick here in the calculator. This is the more exact answer, right? This is rounded, so I'm just going to divide by second, this little button down here, second negative. Will use the previous answer, and I get a more precise answer, which is $3,736.65. Now remember, that's the principal plus the interest. That's how much I pay back. To get just the interest, take away the $3,500 that I originally borrowed. So from that, remove 3,500. Extra zero. And what I get is an interest amount of $236.65. And that's on the discounted model, right? So comparing, which one has the lesser amount of interest? Well, it should be pretty clear that it's the simple interest model. This is a smaller number than that one. So keep in mind that even though the interest rate appears to be higher at first glance, you're actually paying more with the lower rate because of the model of loan. It's a discounted loan, and as a result, you're paying more money with the smaller rate. A little counterintuitive there. So the better model in this case would be the simple interest loan. Let's take a look at some more discounted loans, this time in the context of a treasury bill. If a broker bids $49,052 for a 6-month treasury bill worth $50,000, what is the discounted rate of interest on the transaction? So that sounds quite technical, but thankfully it's just another application of the same formula, where this is the amount that is actually received by the government, and this is the amount that they have to pay out. So since the value of the bill is worth $50,000, in 6 months the government has to give the broker that much money. The broker only lent this amount, right? So you can see that the broker is going to make money by lending it to the government, and that's how this whole transaction works. So I'm going to plug in Q for $49,000 and the loan amount for the face value of the bill. And it's 6 months, so that's half a year. And what the question is, of course, what's the rate? So we have $49,052 equaling a $50,000 treasury bill. 1 minus the interest rate, which is unknown. 6 months is 0.5 years, of course. And there we go. So to solve for R, I'm going to divide both sides by 50,000. So 49,052 divided by 50,000 will give me this amount, 0.98104, is equal to 1 minus 0.5 times R. A couple ways I can go here. I'm going to subtract 1 from both sides. And that gives me a very small amount, as you can see there. Let me try to juggle these pages. So I subtracted 1, and what I got from the calculator was negative 0.01896, and that's equaling negative 0.5 R. So that's this value right here. Divide both sides by negative 0.5, and the R, if I divide this by negative 0.5, is this number here, 0.0379. And that's a interest rate as a decimal. To get it as a percent, the way interest is typically presented to you, multiply by 100%, so times 100%, and what you get is 3.792%. So lending the government some money over 6 months, you get a 3.79% interest rate on your loan. So pretty good money for lending the government your own money for a little while. Finally, let's take a look at this scenario here. At auction, 1 month treasury bills worth $1,000 were sold each for $998.20. Right. So remember, this is how much the government. This is how much the government receives, right? And then this is how much they pay back after, in this case, 1 month. How much interest would be received on the maturity date, which is a fancy way of saying when the loan comes due, when the government has to pay it back, for an investment of $30,000. So go ahead and think about how many of these bills you actually have to buy in order for this investment to work out. And then what is the annual simple interest rate for this investment? So let's go ahead and figure out how much money the government is paying for every $1,000 that they borrow, right? So all you got to do is to calculate the difference in these numbers. $1,000 is the amount the government pays, minus $998, which is the amount they originally borrowed. And that'll give you a pretty small number in terms of dollars and cents. 1,000 take away $998.20 will give you $1.80, right? So for every $1,000, the interest rate is $1.80, or the interest amount rather is $1.80. So notice this says how much interest, not as a rate, but just how much money. So that's per $1,000. So the bank here, or rather the lender, provided the government an investment of $30,000. So they basically purchased 30 of these instruments. So if every $1,000 nets $1.80, simply multiply that by 30, and what you get is the total amount of money that the government paid to borrow the money. So 1.8 times 30 will give me $54. So that's the amount of interest that the lender earned, which if you think about it is not very much. You give the government $30,000, and in a month later they pay it back, and they give you $54 on top of the $30,000. But the government's a very reliable payer, so it's a pretty safe investment, right? It's a way to save money, or to make money, just by keeping it in safe hands. The question is then, what is the annual simple interest rate for this investment? All right, so let's think here for a moment. We invested, so the formula for interest is equal to principal times rate times time. The interest amount was $54, right, on the whole investment. The principal we put in was $30,000. That's how much we lent to the government. We don't know what the rate is. And the time is 1 month, which in terms of years, of course, is 1/12 of a year, right? So these two are both being multiplied together. So I can rewrite that as their product. 30,000 times 1/12 will give me 2,500 times R equaling 54. Divide both sides by 2,500, and I have my R value. 54 divided by 2,500 yields that decimal there, 0.0216, which is a percentage times 100%. Gives me 2.16%. Not a bad rate, just giving the government your money for a little while, they pay it back to you, and you earn 2% on top of that at an annualized rate. Right, so this is only for a month, keep in mind. Alrighty, so a couple examples there. Hopefully, some of the homework problems you have trouble with, this will clarify those. Hope this helps.